Imports and setup. Import requests are used to give you the ability to call web APIs and download JSONs from URLs. Import pandas as PD lets you work with tables of data, like data frames. Import matplotlib.pyplot as PLT import seaborn as SNS is used for plotting charts. Import numpy as NP provides fast numerical helpers. PLT style use sets a clean default style for any plots that are made, but doesn't affect the data. The F1 API stores the base URL for the Ergast F1 API so that we can build full endpoints later. To fetch the API data, we use fetch Ergast, which builds a full URL by joining the F1 API and the endpoint. We also use requests get, which sends the HTTP request, response raised for status, which gives an error if the server returns failure status, response JSON, which parses the API's JSON into a Python dictionary and returns it. We pull multiple seasons and merge them together from the years 2015 to 2025. And we use all results, which is an empty Python list, to help hold the data frame per season. We loop over seasons with get race results. We add new columns to every row for a seasons table with df season. And we add the whole season's data frame to the list with all results append. We then pull and flatten the 2025 season with fetch Ergast, which downloads the 2025 race results. And then we get into the JSON to list the races, MR data, race table, races, and run nested loops over the races and results. For each race, we run the result copy to get the driver's results. We add race fields, race name, round, circuit name, season, and we use results append row to append this enriched dictionary to the Python list. For the effects on the rows, each driver race result becomes one future row in the table. We're building a list of row-shaped dictionaries. We use pd.json normalize to convert the list of dictionaries into a flat data frame. We also use Boolean logic to return a 1 for a race winner, and non-winners are removed. We use similar logic to aggregate wins and points per circuit by driver, with wins, total points, reset index, and effects on rows. And then we pick the top winner per circuit. We show the final results table with display result _df.
This function calls the fetch Ergast in order to connect to the endpoint, retrieve the data, use an empty list to iterate through the data, and then append the results along with all these columns to the data frame. We call the function get fastest laps, store it in the fastest laps data frame, and then we plot it after iterating it through the fastest laps and the driver, and then we append, or we check if the driver is equal to, and then we'll plot it. For the points progression, we iterate through the top 10 and check the points using the race results data frame, check if the driver ID is equal to the driver, and then sort those values. Track performance. We store the race results data frame in circuit stats and then group by the circuit name and the driver ID using a lambda function to convert the value to a number and calculate the mean in order to display this data. Here we take the race results data frame, group by the constructor name, and then store in constructor stats. This is the team rankings, and then call a bunch of lambda functions to convert the numbers into the numeric and then also calculate the sum, mean, max, and mean. And then we print it. And then we take that data frame again, convert the position to numeric, and then group by the driver ID and the last name and calculate all these. Clean up the column names using these functions, and then just visualize it using box plot with the last name as the x-axis. And then these two functions, the first one converts the string into time in the time delta for the pandas. And then this gets the lap data time by calling the API and then appending all of these timings to that frame, storing it, returning the frame. We store the function lap times, and then we apply the convert lap time. And then we create the track analysis by grouping by the circuit name, looking at the best performer, grouping by the circuit, joining it with the lap time stats for the track, and then formatting the lap times to get this. pit stops, connect to the API, iterate through the races to get the pit stops, and then just calculate that and plot it. Lastly, we look at all of the years in F1 and go through the season in the range, connect to the API, get the data, iterate through the races. And then for the circuit and the circuit name, we look at the number and look at the result in each of the race. And if they were number one, then we append the driver to the list, and then we'll return it. And we create this wins data frame. And then we'll group by the driver name, last name, circuit name, count it, sort it with the Lambda function. And for each top driver, we group by and then check the max wins and then append the top circuits into this data frame. And then for the circuits, we group by, find the max, iterate through the rows to append all these. And this is what we get.